That you can keep extending. Yeah, you can keep extending.
Not all courses will have that thing.
Extending.
At least half of it will finish. 2 or 3. How much is pending? So much?
5 lines.
5 days?
Finish it before he can.
Finish it.
Or
Finish it before he comes.
Otherwise, again, we have to sit for another 1 hour.
the recording has been started.
Nothing right now.
Okay. This calculates the squared summation of the weights.
Zoom in a bit.
Yeah.
Yeah.
So we calculate the loss.
What is that hash sign of page 0.5?
No, we start the back propagation. for the last weights. Now we start calculating for all the layers.
What's the symbol for that?
by minus 1 in the for loop, right? As last parameter, what does that do? So this is counting down. So minus 1 is the step length.
That's the increment value.
Yeah, the increment value. So it's just decreased by minus 1. Right?
Yeah, we do.
That's it? Yeah. So this is the end of the function. We need to save this as a .py file in order to be able to import it into other files to use it as like a library. And I have already written it and named it as fully connected net. Okay, this should be good. So far whatever we have written is just saved as .py file, and we can open a new file. No, hold on. Sometime. Yeah. This code is in the GitHub, right? The code is in GitHub, right?
Really? Okay.
So the 0.5 over here is because the regularization has to be scaled by 0.5. That is given in the question.
No, it's because it's half and then weight squared. And then the gradient will be 2 into half into weight squared.
Yeah,
so
2
it
into
becomes-
Oh, okay, because you are calculating that mean square, no?
Yeah.
Top. So we can call this function, create an object of this class and call these functions
Yes.
to get the data from
Yeah.
those images.
Yeah, so
And then,
the CS231 and library already has all other functions defined. So
Oh,
get
okay.
data is one of them.
oh, okay. Okay.
So what we have defined right now is just a class
Mm-hmm.
for creating an object that is of type fully connected neural net. So
Oh.
if you want to create a fully connected neural net,
Mm-hmm.
then we can use this class.
Okay. Okay.
We'll-
And so if we create an object of this, And then you said if there is a function to get the data from there,
Yeah.
from the
Yeah.
downloaded images.
Yeah.
And that data we can pass to where? Which function here?
So first you need to make a model. So this class will be used to make a model, and then there is another library called the solver,
Okay.
which takes in the model and the data, and
Okay.
it will generate the output.
Okay. Okay.
So that solver has a function called as train. So based on what inputs you have given it, it will train the model based on the with the data that you have given,
Okay.
and you can use that to generate the outputs.
Okay.
Yeah, so when you create a model using this class, the first thing you'll be giving is a list. This hidden limbs is a list which consists of the size of each hidden layer that you are going to pass. Then you can pass the number of input dimensions you want, which gives you this because we are now for our data set is that. And the
Number of classes is
number of
10.
classes is already
For this
defined
one.
as 10. And you can pass the weighted scale. This is how much you want to scale your weights by.
Is it that the
Can I
learning
explain further?
learning rate or something?
Scale, weight scale.
So, see the weight, if you imagine the weight as a line, and the weighing scale is just a scalar value. So it just like how much you want the magnitude of the weight to be. So when we are generating the weights, we are going to generate it with respect to the weighing scale. So your standard deviation will be this weighted scale. So if you see, okay, we are not generating it. So when we initialize the weights, we use a normal distribution. And NumPy has something called as a normal distribution, which will generate a distribution of values between mean, like by taking in mean and standard deviation. So for this, we are using the mean as 0 and standard deviation as the weighted scale.
Oh, okay. So this is just the value of the standard deviation.
Yeah.
Okay.
Of course, D type over here will be float 64. We use for the image.
Let's run it.
Yeah, we need to write the. You guys need to save it as a .py file.
And then
Then we need to just import it into a file and run. I've named my file as fully connected net, and this data utils has a function called get cipher data. This function is used for loading this data set into the program. And then this is the solver I was talking about. The solver is another module that is present within the library. So the solver takes the model. So if you see the model, we just create a model. Here we are just passing like we want 5 layers. So we pass these values.
So
And
the
we-
hundreds are number of the hidden units in each layer.
Yeah, the number of nodes in each layer. And we're taking weighing scale as 3.11 into e power minus 4 and
It's very specific.
so 2.46. So I chose these values because I did some trial and error and the output was coming best for these values. And for the solver takes the model, the data, and there is a value called print FD. So that will print the output only for after so many number of iterations. Here is 100, and you can select number of epochs and batch size. The 10 and 250 are standard, and by default the update rule is a stochastic gradient descent. So if you want to use stochastic gradient descent, you don't need to give any update rule argument here. There are other update rules that I have also implemented, which you can directly use. That is stochastic gradient descent with momentum and Adam. Adam is supposed to be the best. RMS prop is also good, but Adam is the one that gives the best update. Okay. And of course, you pass the learning rate using this. So the learning rate is for the update rule. That's why the optim is the module in which all these update rules are defined. And then you just call solver.train, that trains your model. And this is just, if you, by writing like this, even if you have multiple models, ultimately in the end we can calculate the, ultimately in the end we can calculate, get the values for the best model, and then we try to find, we get the mean out of it. That's it.
So I have a question. Can you go?
Yeah.
So okay. Say when you declare fully connected net, right?
Yeah.
And now it's passing 4 parameters, right?
Yeah.
So if you go to fully connected net,
Mm.
I'm trying to connect how it is gonna. So okay. Now whenever you are passing like 4 parameters, it will go to init function.
Yeah, it will go to init function, and the hidden underscore dims gets initialized with that value.
And you don't need the other parameters.
No. So we have already said, since these are going to be images, so this will be the same. You won't change it. So you don't need to pass it again.
My
And now-
question is like when you call that way, it works because when you
But you've given default values.
Yeah.
Huh?
This
But
is,
you've given default values.
Yeah.
If you don't give default values, then you have to pass it.
so if you see hidden dims doesn't have any default value. So you need to pass it every time you call.
also you just pass the value which hasn't been given only, and that
So
works.
basically what happens is you can pass those values and it will override it. But if you don't pass it, it will take these default
Default values.
Also, okay, it will go to the one which hasn't been defined. See,
Yeah, no, it'll go to the first one. If you want to now give in seed, you will have to pass everything. Or you have to pass it as seed equal to when you're calling it.
Yeah. if you're not giving.
What I'm trying to understand is here like we have number of classes equals to 10, right?
Yeah.
So let's say if we want to change to number of classes into 12, right? So
Mhm.
we're gonna define in that other calling function.
Correct.
Yeah.
Yeah.
So when we call over here, we'll just give number of classes equals 12.
Oh my god.
So
Okay.
you just write
Okay, so
num underscore classes equals 12.
okay, I see. Cool. What is the number of classes written there?
Over here,
Yeah.
so I'm not writing here because I'm going to use the default number of classes.
And weight is scale. Okay, I see.
Yeah. Stop it. Please stop.
Thank you for this topic.
Okay, thank you.
Where do you stop?
Just pause.
सेव हो जाएगा ना ऑटोमेटिक.